Hi, I'm Christopher Drogan, Corrosion Technologies. I'm the technical director. We're going to do a quick demonstration of our ground glue products. We're going to start with showing some basic field tests that you can do to characterize the texture of the soil, and then that'll relate to building soil structure with our products. It's kind of a down and dirty, and there really isn't any other way but to go out to the field, get dirt, and pull it out and play with it. When you're in the field, you'll take notes of the locations of the samples, get them from representative locations over a length of product, length of area. You may get representative samples along the way. Larger areas, you want to do more samples. This came from a site that we suspect has high clay content, and we'll be talking primarily about high clay soils. Within the dirt, you want to get a representative sample at about the depth that you will be applying and treating and building soil structure. Here you can see that we've got kind of the root zone and some foliage. We really don't want that in there. If you have a sample with a lot of aggregate, gravel, you'll see that this has worms in it, grass, but it really is down and dirty. Break it up, get a representative sample of the depth and area that you'll be treating. Pull out obvious things like the grass and gravel. You want a good size sample. We're going to be applying 2 different samples and one with just water. So I want enough sample to do 3 demonstrations. So these samples are field samples that are representative of what's done in the lab to determine soil texture. We talk about the texture as we look at a soil structure that we want to build. You build different soil structures for different reasons, but knowing what's out there and how it changes with the use of our products is important to get you to the soil structure that's desired. These tests are typically performed in the field, but like we're doing here today, they're also brought back and done in a more lab environment. I broke apart the soil to get a lot of the roots and plants, but it's not important that it's perfect. The first thing you determine is just how it is out there, and you should note, about how wet the soil is, if it's very dry, if it's very moist. The products are applied with moisture, so you'll be adding moisture, but you should get a good idea of how this is wet and how much plasticity that it has in it. As you can see, dosing a site takes a certain amount of mechanical energy. At times it's just a spray application where the water is a carrier, and just water and gravity will dose that site. Other times you may have to use compaction, and you want to get an idea of just a very tactile idea of how much work it takes to compact the soil and to work a dose in. The first test that I do is just a ribbon test to give me an idea of plasticity. Plasticity, usually you want in a range, the plasticity index of above 5 and less than 25, where essentially you roll out to determine how much like Play-Doh it seems to be. If you can work it into a very thin ribbon, it has a high plasticity index. If you can't work it into a ribbon at all, it has a very low plasticity index. This is a clay sample. It's very typically, it has a very high plasticity. We do want to see that we can get some workability with it with the ribbon test, and just kind of how far out. It's important to note on larger sites, when I said that you take representative samples, that you may notice that your soil texture changes And you'll see, immediate visual clues, but as you start breaking it down to determine texture, plasticity, workability, different moisture contents, you'll find that your application may vary between those different sites. That's why it's important to get representative samples and work those samples separately. So the soil texture tests that I'm going to do are going to determine this soil by the amount of silt, sand, and clay. You never really get a clean, pure sample of anything, but soils that have different predominant characteristics really have to be worked differently. And if it changes on the site, you'll account for that on the site. In addition to the amount of moisture that may be out there, or even the climate may change while you're applying or from start to finish of the project. So the following tests I'm going to do are going to be about determining the soil texture in a very basic way, but very representative of what a geotechnical engineer may do in a lab. After determining plasticity, I do a quick and simple drop test. You just take a ball amount quantity, form it into a ball, and you do two things on it. You pat it in your hand just to see if moisture comes out as you're compacting it. This is very dry and it's holding its moisture. If it had like a glistening, or you could actually wring moisture out of it, you get a good idea of the characteristic of the soil. This is very, very plastic, very, very clay-like. I feel like I might be playing with my nieces and nephews with a good Play-Doh. And then the quick and simple drop test. It's just a matter of tossing it at a flat surface and seeing what happens to your ball. And that's just a smush. The smush test, obviously a high clay soil. If this had had sand or a lot of silt in it, it would have broken up in different but predictable ways, characteristic of that soil texture. The next test I do is a little more definitive and gives you a lot more detail. It's really a gravimetric separation of the sand, silt, and clay. It's a nice, easy way to distinguish in a more measurable, quantitative way. Again, you'll see that there's a little grass in here, and that's okay. I think I just put a worm in there, and that's okay. But you want to get a measurable height, and you're going to break it out by percentage of the total height of your sample to the percent of sand, silt, and clay. Sand is the heaviest and most rock-like of those. It will essentially fall out first and stay on the bottom. Silt's an in-betweener. It has some very small particles and some heavy particles. And then clay, which is also called fines, is very, very light and will fall out last. In a finished sample, you will see that you'll see maybe some gravel in there that you discount. It's not part of the soil texture classification. And you may see organic matter, foliage, and worms, and that doesn't count as well. Then it's just a matter of shaking and waiting. You want to see that your soil is broken up by the water. You also get a good idea of how dry the soil is when you do this, and you'll see that dry soils take very long sometimes to hydrate. You want it to be fully hydrated. You can't overshake it. You want to ensure that the clumps that you see in the soil samples don't persist in the jar. Give it a good shake and then set it down and wait. This is one that I prepared before the video, and you typically want to wait at least an hour. You want to see that the stuff that's in the water starts to become clear, and if you wait an extended period of time, it'll become very clear. So after waiting a couple of hours, where this water is starting to clarify, you'll see that our sample has stratified into two distinct layers. On the bottom of this, there is very, very little sand, but not a measurable quantity. On this sample, I got about 5 centimeters in total height, and about 60% of that is the top layer, and about 40% of that is the bottom layer. So in the 3 soil textures that we're looking for, we see little to no sand, about 40% silt, and about 60% clay. With those percentages known, there's several different ways. Some of them are tabular. This is a graphic produced by the U.S. Geological Service. It's a classic soil texture triangle where, with your known percentages of clay, silt, and sand, you read the clay horizontally by percent. You read the silt in this direction by percent, and you read the sand in this direction last. You usually will see an agreement because it adds up to 100%. In this case, we have very, very low amount of sand, and so we read 60, and we can already see that something that's 60% clay is always going to be clay. But 60, 40, and that's a clay soil. That is consistent with the other field tests that we did and is likely to be reproduced in any geotechnical lab, regardless of the method used. The next step I'm going to do is actually applying the products. So I'm just going to divide the dirt that I have prepared here into 3 samples. One is going to be untreated, and I'll be using plain water to get it into a moldable sample. My aim is to get 2 by 2 by 2 cubes, and this is very, like everything else, is very tactile, very hands-on. In my sprayer, I have just plain water, and I'm going to reserve this as my control sample, essentially. As I add the water, I am taking notes about the conditions, as this is a representative sample, the conditions that I'll be encountering in the field. Typically, moisture is added as a carrier, but you'll find that some soils are very dry, and clay soils are typically very hydrophobic, that it will actually reject a dose. So as I'm getting my hands in here and getting an idea of the amount of mechanical work and the site's conditions, I am taking note of just how much moisture that is. How long does it take to go through the layer? How much moisture does it take to wet the soil to where I can manually compact it? And at what point is there too much moisture? Too much moisture, you'll find, will stick to compacting equipment or moving equipment. And I'm starting to see now that this is going from something that's easy to compact to something that's starting to stick. And that's probably about the right amount of moisture. We do want to give it a couple minutes to hydrate. And in addition to this being a ton of fun, I am getting an idea of what I already know through experience, is that it's very hard to dose clay. I'm going to just do basically knead it, which is representative of what maybe a sheep's foot compactor may do. And it really is just molding this into approximately 2 inches by 2 inches by 2 inches. I try to go for 2 inches because that's typically, unless you have very heavy equipment, about the depth of a layer that can be compacted. This is a very workable soil. Without moisture, it took a lot of mechanical energy to knead this, and with moisture, it's fairly straightforward and easy. You'll note that I'm talking about compaction. Compaction is the best way to build soil structure. It becomes more and more critical when you start looking at the load system that's going to go on that improved surface. Compaction removes moisture and the voids caused by moisture, as well as air that's either natively there or from biological activity. I'm finding that this is a very easy soil to compact, and we'll speak a little bit about what this test does and how it relates to compaction. I'm preparing a 3-to-1 dilution of the ground glue soil stabilizer. This is a product that's meant to be used when compacted, so we'll need very little of this, as the moisture test showed us. It's 100 milliliters of product to 300 milliliters of water. As you're doing your calcs, if you have a tank, it's basically divide by 4. That's the amount of soil stabilizer you want. It is pretty much self-mixing. So requires no aggravation or stirring. So with our plain water sample, we're going to set that aside and move on to the soil stabilizer. We diluted it 3-to-1, and we're going to do the exact same thing. It's critical that you compare, particularly the kneading. It kind of doesn't translate to camera, but as you do this on a larger and larger scale, the amount of mechanical energy needed to dose a high clay soil can be extreme. One of the functionalities of the soil stabilizer product is that it's an aid in compaction. So I'm going to add approximately about the same amount of moisture and I'm just being tactile to see where that tipping point is on a soil that's too dry to work or too wet to work. With this, I see immediately that it's compacting, it's a smaller volume, and that it's taking less mechanical energy to do that. The same kind of kneading mechanism to dose the high clay soil is taking a lot less effort right now. And typically on a project, when you're building soil structure, the more complex you get with it, the more important the compaction ratios are. This still feels a little dry, and it's not sticky. I don't know if the video shows that as I'm applying this, as it's compacting, you see that the moisture is sitting on top. We should make a note of that as you're compacting. If you over-apply moisture of any kind on a clay, you'll find that it gets very sloppy, and there can be a tipping point that it could be completely unworkable. Okay, so we have our second sample prepared. We're going to let all of these dry, cure, react for about 24 hours to compare the differences. So the third sample we're going to do is the ground glue dust and gravel formula. It has a different mechanism and different expectations when applied to a high clay soil. It's very good at breaking up the ability of clay for heave, the shrinking and swelling, moisture uptake, and it makes a much harder, more brittle surface that may have a place in some soil structures depending on the desired effect. So I'm going to do the last sample. We're going to do this at a 1-to-1 dilution, 200 milliliters of dust and gravel, 200 milliliters of water. It is also self-mixing. It takes very little agitation to combine the water and the product. We'll add about the same amount of moisture and see how it feels. Again, a very tactile demonstration of how workable the soil is, its moisture uptake, and at what point we're adding too much moisture. Same basic kneading action that is helpful to use on clay soils. Visually, I don't know how it comes across on the camera, but by feel, all three of these have felt very different. And seem to require different levels of moisture to get the soil to be workable. As I said, the dust and gravel formula makes clay harder, and I'm feeling that immediately. I'm getting at that point where it's starting to feel sticky, starting to stick to my hands. And I know that it's had just about enough moisture. That's our third sample, and we'll evaluate these in about 24 hours.